Applications of differentiation. We are going to continue with tangents and normals. You will find this on page 270 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Equations of a tangent and a normal. Find the equation of the tangent and of the normal to the curve. The function is just a little bit more complicated at the point where x is -2. Now, if it's more complicated, then we will always go for the chain rule. But before that, let's just find the y coordinate. We have the x coordinate, but we must still find the y coordinate. Okay, so basically we take this -2 and we substitute it in the original equation. And if we do that, we get -3. Okay, so you must have the full coordinate. So now find the derivative function and the gradient at the point. Now, because the function is more complicated, we're going to go for the chain rule. So remember, take it out of the root and bring it up. And now, if you go for the chain rule, now what I did here is I actually did the short way. So can you still remember the short way? Is we're going to differentiate the outside, okay? So if there's -1, so it's negative the third times 3, this, multiply this, multiply that we differentiate the inside. Okay, but you can do it separately. You can use u, which will be easier. I think in the videos to come, I will use the shorter method, or first the long and then the short, so that you can have just a reference to the shorter one. So when x is -2, now we want to find the gradient. We substitute the x value in, we get 1. So therefore, at the point the gradient of the tangent is 1. Now we use the formula and we substitute the point in, and that is the equation of the tangent. And now for the normal, you can actually just use this formula and now just substitute 1 divided by -1, or the 1, and the negative is just, can you remember, perpendicular? We change the sign and we take the reciprocal. Substitute again, and that will be the formula for the normal, which is 90 degrees to the tangent. Okay. Actually, most of these things we already did. It's just now putting it into one sum. So I want you to stop the video, take your time, do number 1, B and C. And don't forget to use the chain rule and basically the previous methods. Okay, I'm going to start. 1B. Okay, first let's write down the function. And it's x is 9, but we don't have the y coordinate, so let's first go for that. So the y coordinate, y, x is 9, and that's going to be y equals, and I'll just substitute 9 in the place of x. So that's going to be 2 and the square root of 4. So it's 2 times 2, which is 4. Okay, so therefore, okay, let's say therefore, the point will be 9 and 4. This is the point where it touched the curve, where we want to draw the tangent. Okay, now we're going to differentiate. Now again, I'm going to show you both. I'm going to show you now, I want you to introduce the short way. It's going to spare a little bit of time. So let's first go d. Yeah, I think I'm first going to take the function because we take the chain rule. So first break it up. Make u the inside. And then just go it like this. Now I differentiate, so it's dy over du. Don't forget that this is equal to 2u to the power of a half. Half didn't go in nice. Okay, So this will basically be 2 times a half, and as soon as I subtract a half, so minus 2 over 2, I will get negative a half. And that will be okay, that will be 1. So it's 1 over, and now I take it back to the root. That will be, and if I differentiate here, du over dx, and that will just be 1. And if I multiply it, I will say dy by dx. And now I substitute u back, so it's 1 over x minus 5. Square root x minus 5. And can I just show you the short way? So I'm going to try to do it here on the side. So the short way was just, if you look at this, just be careful. It will first be the outside. So you have to take this formula also to y equals 2 bracket x minus, it's this one, x minus 5 to the power of a half. So if I differentiate, and I'm just going to dy over dx, I want to introduce this more to you. So first the outside, okay? So it will be 2 times a half, and it's x minus 5 to the power negative a half. And then I just multiply, my space, let's just get more space. And then I multiply, I differentiate the inside. And what will the inside just be? 1. And that becomes 1. Can you see? And if I move it down, it's 1 over. So it's actually very easy, the short. So first the outside, multiply by the inside. And that exactly gives you the same. I will use it more, but first I will use both. And as soon as you are familiar with the short one, later on we're just going to use the short one. Just make sure that you don't forget to multiply by the inside. Okay, now as soon as I'm here, I want to find the point. So the gradient at the point, and I'm just going to say it here. So the gradient at the point where x is, where x is 9, this is going to just be dy over dx, and just substitute 9 in the place of x because it's that 9. So it's 9 minus 5, and it's 1 over the square root of 4, which is a half. Okay, so what is that gradient? That gradient is a half. So now I'm going to say the equation. What color didn't I use yet? White. The equation of the tangent at 9, 4, and that will then be, okay, don't forget the point. Can I just show you? That's x1, y1. So it's going to be that formula. I can write it first. Y minus y1 is equal to mx minus x1. So it's going to be y minus y1, which is going to be 9, is equal to mx. I was putting it incorrect. Did you see? I was putting the x. Usually you will, as soon as you substitute again, you will see it. So first the y, and then the x. And if I simplify this, let's just take this to this side. Then I'm going to say y is equal to, okay, I forgot to substitute m also. Okay, So what was m? Don't forget m, this was the gradient, this is m, that was a half. Okay, just want a rubber. Let's redo that. So this will be y minus 4, and that will be a half x minus, it's 9 over 2, minus 9 over 2. I think it's better if we're going to make it, let's leave it 9 over 2 first. And then I'm just going to say it's a half x minus 4.5 minus 4. I think it's better if we write 4.5. Plus. So it's minus 4.5, not minus, but plus 4. So can you see what is left? So therefore, y is equal to a half x minus a half. And that will be the tangent at the point 9, 4. Remember, it's just at that point to the curve. Okay, I must move up a little bit. I will now clean again. And now I'm going to, I have all the information, so it's very easy now to find the normal. So remember, the normal is perpendicular. So, and I'm going to do it like, I want to just take another color. Okay, so the equation of the normal, so the equation of the normal, and I want to write it first for you down, and you don't have to, you can swap it inside the formula, because there it's showing the negative and there it shows you the swap. Okay, I still need a little bit space. Okay, so basically, if you're going to say y minus y1. So if you're going to look at y1, let's not make the mistake again. So this is x1, this is y1, so this is 4. And now I'm going to swap it inside. So, okay, it's going to be a bit more challenging, because it's going to give you, I want to show you here, it's going to be negative 1 over a half. Do you see? So basically, if you multiply by the reciprocal, it's just going to be negative 2. Okay. So I decided to do it rather on the side there. So I just can substitute. So x minus, and now don't forget that it's going to be 9. So y minus 4 is equal to negative 2x plus 18. So y is equal to negative 2x plus 18 plus 4. So therefore, y is equal to negative 2x plus 22. And don't forget, this is the normal at the point 94. Okay, that's how we do it. Let's do another one. Must move up just to get space, and I have to clean everything. But as I said, we were building up to this kind of sum. So if you watch the previous videos and if you practice the previous content, then this will be easy. Okay, now I'm going to do number B. So that was number A. And now I'm going to do number C. Okay, let's start with C. Now again, I choose this one. Why didn't? Because you already did a root. And I was liking that that 2 was in front of the root. Okay, but in this case, it's now the variable is in, the x value is in the denominator, so I must take it up. It's in the chain rule. But I just like the fraction, so that's why I wanted you to do this one. Okay, so again, we are going to start by first finding we have the x value, but we must find the y coordinate. So the y coordinate where x is 3. So I just substitute in the original equation. So it's going to be 20. This is 9 plus 1 over 10. So it's going to be 2. So what is that point? 3 and 2. That is the point where we must draw the tangent. Okay, now we're going to start. Now we're going to differentiate. So again, I'm first going to do the long and then I'll show you the short. So the chain rule. So bring u in. So what will u? Okay, I don't want you to be so far. Then I don't have space for the short one. Okay, so in this case, before I start, I first have to get it in this form. Can I just show you here? It's 20 over, and you put it in brackets, and it's positive 1. But if you bring it up, it will be negative 1. So I want it in this form. And then I can go into my chain rule. So because then I can see u is the bracket. And what is the bracket? Just want to get my color correct. The bracket will be x squared plus 1, and y will be equal to 20 u to the power of negative 1. So I'm going to dy over du. It's negative 20 and it's u to the power of negative 2. So actually it's negative 20 and it's u to the power of 2. Okay, so if I'm going to go on with that one, okay, let's just see. I just want to control something. Okay, and then this one is du over dx. Oh, sorry. Dx, and that's 2x. And if I multiply it, dy by dx, okay, so just multiply this 2, so it will be negative 40x, and u, put u back, and don't forget to square it. So what is u? So it's x squared plus 1 squared. Okay, I want to show you the short way again. I want you to get used to it before I'm doing it in the videos. Okay, so the short way was if I'm sitting with this, you have to take this. So it's first differentiate the outside. Okay, so it will be, let's just get my pen correct. It will be dy by dx. So the outside will be negative 20, do you see? And it will be, first write everything down. And subtract 1, and now you multiply by the inside. So the inside will just be 2x. And if you multiply this, you will get negative 40x, and it's x squared plus 1 to the power of negative 2. And then, basically, you just take it down. So it's negative 40x over x squared plus 1 to the power of 2, which is exactly the same. Okay, so get used to the short method also. Now we move on. So now we're just going to find the tangent, the equation of the tangent. What color will we go to? White first. So the equation of the tangent at 3, 2, so y minus y1 equals mx minus x1. Okay, so in this case, this is x1, this is y1. So if I'm looking at this one, so it's y minus 2 equals, oh, I already want to write it down and I didn't find the gradient. Okay, So let's just find the gradient. It's not very difficult, okay? I can maybe just make space for me here because I did it on two sides. And you see, sometimes you continue with a sum and you realize, oh, I'm having something missing. So as I realize now, so it's not a problem. We're just going to find it quickly. It's just a gradient. We're going to use the derivative function. So we're just going to say gradient at the point where x is 3, and that will just be dy over dx, and we're basically just going to substitute 3 and that is just going to give me, after we simplify this, so this will give me negative 120. This is 9, okay, can you see? This is 9 plus 1, so it's 10, squared it's 100. And if I simplify that, it's negative 12, so it's going to give me a gradient of negative 6 over 5. Okay, so now I have my gradient, you see? So it's going to be negative 6 over 5, and it's going to be x minus x1, which is 3. And now I move up a little bit. Then I'm just going to say y minus 2 equals, okay, this is negative 6 over 5x plus, we can just keep it 18 over 5, which is going to give me y equals negative 6 over 5 okay, remember 18 over 5, it's going to be, let's just get another color, it's going to be 3, do you agree? 3 and 3 over 5. And then I'm going to add that 2, can you see? So it's going to be 5 plus 5 and 3 over 5. Because I'm just taking this and I just add the 2. Use a calculator, do it on the side. Write, you can even write 28 over 5, it's all correct. And don't forget that this is the tangent at the point 3 over 2. Remember, it's not the tangent to the whole curve, it's just at that specific point. Okay, now we're going to continue. What color can we use now? Blue. The normal, so the equation of the normal, I'm going to get the pen correct, the equation of the normal, and remember that it's y minus y1, but we can change it, it's negative, but I can just change it around because it's a fraction. It's sometimes easier. So remember, if that, so perpendicular will be positive 5 over 6, which I can then just simply substitute there. So it's going to be 1 minus 2 equals positive 5 over 6. And it's going to be x minus 3. Exactly the same, just a reciprocal, different sign. And I'm finishing off with this one. Hopefully the pen is going to work here. So it's y is equal to, it's going to be positive, positive. Let's leave the positive out. So let's just say 5 over 6 x. Okay, now don't forget, this is going to be negative 15 over 6 plus that 2. Okay, I just want to show you on the side again. So if I 12, so it's going to be negative 2 and it's 12, it's going to be 3/6, so it's a half, plus 2. So that is going to just, if you subtract that 2, you will just get the negative a half. So y is equal to 5/6x minus a half. And don't forget, what was this? This was the normal at the point 3 and 2. You can still do a few. Just concentrate. We are doing a lot of things, but it's not difficult methods.